Okay, so this is the beginning of Chapter 6, and in Chapter 6 we're going to do a lot with exponents and radicals. So the first thing we want to do is review the exponent rules. Remember that exponent implies repeated multiplication. What that means is that x squared here, x squared, actually means x times x, okay? The 2 tells us how many times x is multiplied by itself. So x to the 5th would be x times x times x times x times x. It is repeated 5 times. It's multiplied by itself 5 times. So how do we handle exponents? Well, there are 6 rules that you need to know. I expect you to get these and master them. If you're in an honors class, we will not review them. Other classes, we will spend a day or two to make sure that you understand them. But these are important to know for the rest of the year. Number 1, adding and subtracting. You're going to combine like terms. Like terms must have the same combination of variables and exponents. So what does that mean? Let's look at a couple of examples. If we have 9x squared plus 16x squared, those are like terms, so we can add them together, and we get 15x squared. If we have 6xy plus 10xy, those are like terms because we can add them together. We say they're like terms because the combination of variables and exponents are exactly the same. However, in the third one, 6x squared y minus 2x squared, we cannot combine because they are different, so that's simplified already. Your product rule is number 2. So if we have x squared times x cubed, we could write it out like this, where it's x times x times x times x times x. Or it would equal x to the 5th. So, is there an easier way to figure it out? Yes, there is. If we have x to one number times x to a second number, all we have to do is just add the exponents. See how when we simplify this one, we get x to the 5th, just like we did up here. So the product rule is simply this. If the base is the same, you just add the exponents together. Our power rule, remember, is where you have an exponent that you raise to a power. So this is also called the power of the power rule. X squared to the 4th could be represented by this x squared times x squared times x squared times x squared, which we now know is simply x to the 2 plus 2 plus 2 plus 2, which is equal to x to the 8th. We also notice that 2 times 4 equals 8. So the power rule is easier because we know if we have a base that already has an exponent, if we raise it to another exponent, all you do is just multiply the 2 exponents. So if we had x to the 3rd raised to the 5th, that would be x to the 15th. If I had x, y, and let's say the y was squared and I cubed the whole thing, then I would have x cubed, y to the 6th. The quotient rule is just like the inverse of the product rule, okay? So we're going to take x to the 5th over x squared. If I write it out, I find that my 5 x's are on the top, and I have the 2 x's on the bottom. If I start simplifying, x over x is equal to 1, x over x is equal to 1. I know that I still have 1 in my denominator, so I end up with x cubed. What I find is that x over a, x to the a over x to the b, I can just subtract my exponents. If I have x to the 5th over x squared, that's x to the 5 minus 2, which is x cubed. And see how these are the exact same. Negative exponents are unique because you have the opportunity to make it positive. If you're not comfortable with dealing with negative exponents, or if the problem requires you to use only positive exponents, it helps to know what to do with them. Simply, a negative exponent becomes positive when you move it to the other side of the fraction bar. If I had x to the negative 5 and I needed a positive exponent, here it would become positive. If I have x to the negative 1 over x to the negative 3 and I want a positive one, I just simply move it to the other side of the fraction bar. Please make a note, though, that a negative exponent does not mean anything with regards to the sign of your monomial, okay? This number doesn't affect whether this number is positive or negative. The zero exponent rule means x to the 0 is equal to 1. 29 times x to the 0 is still equal to 29 to the first, 29 times 1, which is still 29. One thing I want to let you look at too for the final rule is the distribution rule. If I have a x quantity to the 5th, then that's going to be the same as a to the 5th, x to the 5th. If I have a x to the 5th over y, if I have that, I'm still going to distribute it. It's going to be a to the 5th, x to the 5th, y to the 5th. Okay? And that's how we distribute exponents. Okay. If you're in my 2A, my 5A, or my 4B class, you should have received a packet when you finished your test. I want you to go back and watch this video again and complete the front page. And then begin working the problems. Okay? Yes, there are 50 problems. Once you get the hang of it, they'll be easy to do, and I expect the handout to be due by the next class. So it's due Monday or Tuesday. You can also, if you lose it, you can also get a copy of it off Orban. I'll go ahead and post it there today. See you later.